Okay, so this should then help you with the completion of task 3. So you should already have the bridge rectifier circuit built. If not, you can build it using the same components and layout as this one here. Just a reminder of where the components are located. You've got your main tabs here for source and basic components. That should cover the voltage supply, transistor, bridge rectifier, capacitor, and these two resistors on the end, along with your ground supply. On the right hand side is your test equipment, which is your multimeter, which is XMM1, and your oscilloscope, which is the fourth one down there. You may need to make some slight changes. Obviously I've already put mine in. You can drag them around and move them where you like. If you right click them, this is where you can change the value. So you may need to change the value of your AC power source. You may also need to change the turns ratio of your transformer. So again, you go either down to properties or replace component and see the type of transformer that I've used. Same with the power supply. That will show you the type of power supply that I've used there, AC power. And then also when you double click on this component, you can change the value by going into the primary and secondary coil, changing the number of turns. And if it matches the ones that I've got, it should work. You also need your full wave bridge rectifier. You can use this with separate diodes, but it's harder to draw it in place. That's why I've used the bridge configuration. And that's located in the diode group under FWB. And I've just selected the 1B4B42 package and put that in there. The rest of it is fairly straightforward. The main thing that we need to look at is what happens when we start changing the components, because that's what's required for the task. Now what we're going to do for that is run the simulation, bring up the oscilloscope. Now mine's defaulted to 10 microfarads on the capacitor, so I'm going to change that to 100 and open up the oscilloscope. If you make any changes, you need to stop and restart the simulation, and to get the scope page up, you double click it. This has now brought up the oscilloscope page, and we can see we've got our two waveforms. One of them is in red, one of them is in blue, and that's because I've changed the input to channel B as a blue wire, and it updates that on the output of the oscilloscope. Now the task requires you to make any notes of any changes to the waveforms and the ripple voltage. So the first thing we're going to do is look at the ripple voltage amplitude. Now we do this by dragging those two tabs from the top left hand corner, clicking on the waveform we want, and you should see two little dots up here, and it's the distance between the bottom and the top of the waveform that we're interested in. Now that value is shown right at the bottom of the page there. So where that says 813.843 millivolts, that is the ripple voltage. The other voltage we're interested in is this peak voltage, channel B. It's the peak ripple, which is 13.9. As we can see, those voltage will change dependent on where we slide our slider to. So ideally you want to get it at the top of the waveform and the bottom, and that will give you a more accurate value for your ripple voltage. Now another thing we need to look at is the voltage across the load resistor. So we can X that off, double click on your multimeter, and this will now give us that voltage across the load resistor. What we will note is that as we start changing the value of the smoothing capacitor, the ripple voltage may increase, and then we can also note down the effect on the load resistor. In order to do that, we'll stop the simulation, double click the capacitor component. I'm going to reduce it now to 10 microfarads, click OK, run the simulation again, double click the oscilloscope, and clearly see now there's a much greater amplitude of that ripple voltage. We're going to do the same thing, drag our little tabs across and go from the lowest point to the highest point, and we can see now that the ripple voltage has increased to nearly 6 volts and the peak voltage has decreased. So using that information, we can see that we've got different values that we can now populate our tables and start to use that for our analysis.